Hello, mathematicians. I hope everybody's doing well. I'd like to share my screen with you and talk about Modular 2, which is sets, whole numbers, number theory, and numerations and computations. So our first question covers the Venn diagram. And I've color-coded it out for you so you can understand union and intersect. And we have our universe here and our set A, set B, and set C. And this right here is not a letter U. This is considered union. So B, union, and C, which I like to think of as and or. So it's going to be everything that's in B and or C. And if we go back and reference our diagram, we would see we had D, F, H, and G. And this union is also called a cup. And then we have A intersect B. And that's not an upside down U. It's called a cap. And I like to think of it as and. So what letters are in A and B? If we go back and reference our diagram, we have D and H. And then we have this A with a line over the top. What does that mean? It's the complement of set A. In other words, it's a set of elements in the universal set U, but not elements of A. If you go back and reference the diagram, you have A, E, and F. Okay, and then we're going to describe which shapes are found in the set L and H. L stands for large and H stands for hexagonal. So we're going to have shapes that are large and hexagonal. Let's describe shapes that are found in set T that intersects the complement of R. We're going to have triangles that are not red. And then let's talk about C intersects S intersects R. You just break it down. C intersects S, which is small circle shapes. And then we have intersect R, which is small red circles. And then we're going to talk about the Egyptian system. And I've written you out the powers of 10 and everything that they represent for easy reference. And in our problem, we had 3 pointer fingers, which is 10,000, and 5 yokes, which is tens, and 4 staffs, which is 1. So you had to pay close attention to your place value on these. So you would have 10,000 times 3, 10 times 5, and 1 times 4, which would give you 30,054. Now let's go to the Roman system. I've given you a diagram that shows you what each Roman number symbolizes in like X equals 10. So let's break it down. M equals 1,000, CM equals 900, 3X equal 30, and V with 2 ones equals 7. Gives you 1937. The Babylonian system, you have symbols, these little icons here that look like arrows and then an upside down triangle. Very important. That is a place value. So you have 10 plus 10 plus 10, 4 times plus 1 equals 41, but pay attention to the place value. You only have 1, so you're going to take 41 times 1 equals 41. The Mayan like to use lines and dots to represent their numbers, and I've drawn out a diagram for you. And I've given you position value, very important. And we have 1, 2, 3, 4 positions. So you're going to take 5 times position 7,000, the fourth position, which is 7,200, 6 times 360, 3 times 20, 17 times 1. You add them all together and you get 38,237. Lattice Algorithm. Loved doing these. These are so much fun. What you need to do is you need to place 28 times 32. So you're going to put 28 at the top of your box, and you're going to draw diagonals in your box. And you're going to put 32 along the right side. You're going to take 2 times 3 equals 6. And you match up the column and the row. So you're going to do 0 at the top and 6 at the bottom of the diagonal. And then 2 times 2 equals 4. So you'll have 0 at the top of the diagonal, 4 at the bottom of the diagonal. 8 times 3 equals 24. 2 at the top of the diagonal, 4 at the bottom of the diagonal. 8 times 2 equals 16. 1 at the top of the diagonal, 6 at the bottom of the diagonal. And then you're going to add the diagonals. So we have 6 right here. 4 plus 1 plus 4 equals 9. 2 plus 6 plus 0 equals 8. And if you want to, you can add the 0 over here. And then you're going to read from, on the left side, you're going to read from top to bottom. And then on the bottom side, from left to right. And that is your answer. How cool is that? So 28 times 32 equals 896. And then 273 times 628 equals 171,444. 964 times 593 equals 571,652. 4,952 times 243 equals 120,336. Estimations. Let's talk about estimations from the most left digit. So we have 883. You need to look at the second 8 in the tens place. That 8 is larger than 5, so you're going to have to round the 8 up in the hundreds place to 900. And you're going to use a squiggly equal sign, which means approximate. So 883 approximates 900. And 465 approximate 500 because the 6 in the tens place is larger than 5. So you're going to make the 4 in the hundredth place a 500. And then 134 approximates 100 because 3 is not larger than 5. So you're going to leave the 1 in the 100th place as a 100. So you take 900 plus 500 divided by 100 and you'll get 14. Now, what about the actual answer? I did that for you. 883 plus 465 divided by 134 equals 10.0. Pretty close to your answer. Or, I'm sorry, pretty close to your estimation. If you need to compute a problem quickly, estimation is a great way to do a problem quickly. And then 5 times 254 plus 523 divided by 35 plus 7. The key to this problem is to add your denominator first. And then do your estimations. And I have 100 after my estimations, and my actual answer is 92.5. And then we have 620 times 430 divided by 293. Our estimation is 800, and our actual answer is 909.9. Okay, now let's talk about base 5 and base 6. I like adding by base 5. It's fun. Okay, so you take 2 plus 3. Here's what's important to know. Just like base 10, base 5 has place values. Base 10, in the first place value, you can only use 0 through 9. With base 5, you can only use 0 through 4. And its place values from right to left is 1, 5, 25, 125, 625. And it can just keep going and going and going. Just multiply by 5. Okay, so you're going to take 2 plus 3. You're going to look at the first column. And you have a 5. You cannot use a 5 there. It's illegal. So you're going to ask yourself, how many 5s can I make out of 5? You can only make one group of 5. So you're going to carry the 1 above the 3 right here in the 5's place value. And you're going to take 5 minus 5 equals 0. Now move over to the 5's. 3 plus 3 plus 1 equals 7. That's an illegal number. How many groups of 5 can you get out of 7? 1. So you're going to take 7 minus 5 equals 2. And then you're going to take 4 plus 1 plus 1. 4, 5, 6. You're going to take 6. How many groups of 5 can you get out of 6? 1. 6 minus 5 equals 1. Then you're going to drop your 1 down. So you have, and it's said like this, 1, 1, 2, 0, to the fifth with the fifth base, with a base of 5. And I'm almost out of time. And I had to watch a video to understand how to add base 6. And what you do is you take 8 plus 3 equals 11. You cannot write the 11. You have to divide 11 into 6 and you get 1. So you carry the 1 with a remainder of 8. Then you're going to add the next column. 1 plus 2 plus 7 equals 10. 10 is illegal to you. So you're going to divide 10 divided by 6 and you get 1 with a remainder of 6. Carry the 1 and bring the 6 down. And then you take 7 divided by 6 with a 1 with a remainder of 1 and you get 1168 with a base 6. Subtracting with a base 5 is pretty cool as well. It's a little hard to get the concept at first, but once you get it, it's smooth sailing after that. And again, you can only use 0 through 4. So you take 4 minus 3. You cannot take, 4 minus 3 equals 1. So you're good with that number. Move to the next column. You cannot take 4 away from 1. So you will need to borrow from the 4, change it to a 3, and you're going to borrow 5. So 5 plus 1 equals 6. And then you're going to take 6 minus 4 equals 2. And you can check and then you're going to drop your 3 down. You can check your answer by taking 3, 2, 1, base 5, plus 4, 3, base 5. And then you have 5, 0, 3, base 5 minus 2, 4, base 5. And you get 4, 2, 4, base 5. And I hope you enjoyed my presentation. I'm now out of time. And I hope you have a great night. Thank you.